Hello friends, welcome to my channel. In this video we will cover objective mechanical fluid mechanics. From fluid flow chapter we will discuss. This is an RRB question, 2019 RRB exam question. The square root of the ratio of the inertia force due to flow to the elastic force of fluid is known as inertia force to elastic force. Answer is Mach number. So Mach number is square root of inertia force by elastic force. Mach number is applicable where fluid compressibility is important. And we know Mach number equal to V by C. V is your speed of flow. C is speed of sound. So from option we will check Mach number. Then Reynolds number also important. Inertia force by viscous force. Inertia force by viscous force. Rho v d or L, whatever you can write. Characteristic dimension or characteristic length. Rho v L by mu. Reynolds number. This one also very important. Then your Froude number. Inertia force by gravity force. V by root over GL. Next question, RRB question, 2019 paper. When Mach number is less than unity, the flow is Mach number less than unity. Less than 1. Subsonic flow. Then Mach number equal to 1. Sonic. Then Mach number is greater than 1. Your supersonic. Then hypersonic. Mach number very greater than 1. Or Mach number greater than 5. Hypersonic. Answer. Mach number is less than unity, so subsonic flow. A streamline and an equipotential line in a two-dimensional inviscid flow field. So streamline and equipotential line relation in 2D inviscid flow. Equipotential line definition: a line along with the velocity potential phi is constant is called equipotential line. And streamline definition: a streamline is an imaginary line drawn in a flow field such that a tangent drawn at any point on this line represents the direction of velocity vector at that point. And streamline and equipotential line both are perpendicular to each other in two-dimensional inviscid flow. So perpendicular to each other, C is your correct answer. Which of the following statement is true about the Pitot tube? So Pitot tube, this is a Pitot tube. Fluid is flowing inside the pipeline. We'll change the color. Its fluid goes up to this height. So this height H is your stagnation height. This device is your Pitot tube. You can use piezometer also. If you insert a piezometer here, you will get static head. Small h. This is your static head. Pitot tube principle is it converts your kinetic head to pressure head. And formula is theoretical velocity is Cv into root over 2g h minus h. Cv is your coefficient of velocity. Coefficient of velocity. Actually, if you insert the Pitot tube, you will get, by using Bornolis equation, you will get velocity head. Velocity head. V square by 2g. It's equal to capital H minus small h. Stagnation head minus your static head. So from here you will get instantaneous velocity or velocity. By using velocity, you can calculate discharge Q. So which of the following statements is true about Pitot tube? RRBJ question 2019. It consists of a short converging part, throat and diverging part. Short converging part, then your throat, then diverging part. This one is your venturimeter. It is made up of a tapered tube and a float inside. It consists of a thin metal sheet having in it a square edge, sharp edge, rounded edge, circular hole. It consists of a glass tube bent at right angles. Yes, this one. Glass tube bent at right angles. D is your correct answer. Next question, RRBJ question. Continuity equation can take the form. So continuity equation, rho 1 A1 V1 equal to rho 2 A2 V2. If fluid is incompressible, rho 1 equal to rho 2, then you can use this one, A1 V1 equal to A2 V2. Continuity equation. So from options we will check. P1 pressure is here, so not possible. Rho 1 A1, P1 V1, A1 V1 equal to A2 V2. If fluid is incompressible or ideal fluid. The imaginary line drawn in the fluid in such a way that the tangent to any point gives the direction of motion at that point is known as, it's on streamline. RRBJ question 2019 question. This one definition of streamline. If you draw the tangent at any point, you will get the velocity vector v, and perpendicular to it velocity is 0. Normal velocity v equal to 0. Here also if you draw a tangent, you will get the direction, and normal Vn equal to 0. This is streamline definition. So B is your correct answer. And one more thing also important here. Two streamlines, another streamline, this one streamline, and this one another streamline. If you draw at this point, if you draw a tangent V like this, you will get two velocities. So velocity V in this direction and another V in this direction. So this one not possible. Two streamlines cannot cut each other. This one also important. The Reynolds number represents, Reynolds number already told, R equal to inertia force by viscous force rho V L or D by mu. L here characteristic dimension or characteristic length also. You can write D also, no problem. R equal to rho V D by mu. So from option, viscous force in a fluid, viscous force to gravitational force, inertia force to viscous force, C is your correct answer. Inertia force Fi and Fv is your viscous force. This one SSCG 2019 question. SSCG 2019 question. Bornolis equation is used for Bornolis equation assumptions we have to take. Flow is ideal flow, or mu equal to 0, or you can write inviscid also. Next assumption, steady flow with respect to time. Steady means with respect to time. Flow parameters are constant and flow is incompressible. Rho is constant. Incompressible means your density rho is constant. Then irrotational flow, then flow is continuous. So from options we will check Bornolis equation, laminar viscous flow, it should in viscous flow. Viscous flow at high speeds, turbulent flow, incompressible fluid, yes. Incompressible means the density is constant. From assumption, this assumption, incompressible, rho is constant. Then next question, SSCG 2019 question, the flow of fluid in a straight smooth pipe becomes turbulent. So turbulent means it related with a Reynolds number. Flow of fluid in a smooth pipe, Reynolds number below 2000 for smooth pipe, laminar flow, R greater than 2000 and less than 4000, transitional flow, R greater than 4000, turbulent flow. So from option we will check, Reynolds number is greater than 4000, A is your correct answer. And Reynolds number is less than 4000, it may be transitional or laminar. Reynolds number is less than 2000, this one laminar, equal to 2000. Then this one for smooth pipe only, Reynolds number. And in case of your open channel flow, this one also important for open channel, Reynolds number less than 500, R greater than 500 and less than 1000, R greater than 1000. This one laminar flow for open channels, transitional and turbulent. Both are important for open channel flow and your smooth pipe flow. Next question, SSCG 2019 question, using the stream function in two-dimensional flow automatically satisfies. So stream function in two-dimensional flow field, and we know stream function exists means it should satisfy continuity equation and flow can be rotational or irrotational. Can be rotational or irrotational. But it should satisfy continuity equation. Stream function exists means it should satisfy continuity equation. But flow can be rotational or irrotational. And stream function, it shows your direction of flow. So equation V equal to, first we will start from U equal to dy and V equal to dx. Both are important. The question you will check, using the stream function in two-dimensional flow automatically satisfy the continuity equation. C is your correct answer. SSCG question 2019. Considering the frictional effect, the isentropic fluid flow becomes. So, if you consider the frictional effects, isentropic fluid flow becomes, this should be irreversible isentropic. Isentropic means adiabatic. So, from option A is your correct answer. Irreversible and your adiabatic flow. Reversible adiabatic means your isentropic flow. Which of the following device used for the measurement of flow rate through a circular pipe with the least loss of energy and direct reading? You will get your direct reading, then least loss of energy. Measurement of flow rate. Flow rate means Q. Discharge you have to calculate with least loss of energy and you will get your direct reading. Pitot tube you will not get direct reading. Pitot tube, first you will get your velocity head, then V, then from V again continuity equation you have to apply, A into V, then you will get your discharge. So with least loss of energy, notch also not possible, orifice also not possible. C is your correct answer. Venturimeter. Converging part, throat, then your diverging part. What do you mean by a streamline? SSCG question already discussed. If you draw a tangent, it will show the velocity vector. Draw normal to the velocity vector at any point, a line that connects points of equal velocity in a flow field, a line that connects midpoints of flow cross section, a tangent at any point that gives the direction of velocity vector at that point. If you draw the tangent, you will get the velocity vector at that point. D is your correct answer. SSCG 2019 question, laminar flow is also called as. Flow is laminar or transitional or turbulent. It is based on your Reynolds number, and its Reynolds number rho v L or D by mu. So laminar flow means your Reynolds number should less. Reynolds number should less means rho v L it should less and mu should high. So from option adiabatic flow, streamline 1 minute. Here options are different. Laminar flow is called as, this one should be streamline flow. And here turbulent flow is zigzag flow. And streamline flow is your laminar flow. So B is your correct answer. In a uniform flow, the velocities of fluid particles. In uniform flow, velocity of fluid particles. Uniform means with respect to space. With respect to space or position. Move in a well-defined path. Then do not change with respect to space at any given time, are always depend on time, are perpendicular to each other. Do not change with respect to space at any given time. B is your correct answer. Uniform flow. If it is a steady flow, then do not change with respect to time. SSCG 2019 question. A pipe of diameter 10 cm carrying water at 5 meter per second reduces into a smaller diameter of 5 cm. The velocity in the diameter section, in smaller diameter section, velocity you have to calculate. So this is a pipe. Then a smaller dia pipe. Diameter, that this is section 1, this one section 2. In section 1, diameter is your du1 equal to 10 centimeter, then v1 velocity equal to 5 meter per second reduces into a smaller dia d2 equal to 5 centimeter. Here in this question, d1 given, then v1 also given, this one d1, then v1. You have to apply only continuity equation, a1 v1 equal to a2 v2. Then here you will get v2 here. v2, the velocity in the diameter section is v2 value you have to calculate. Just apply continuity equation, you will get your answer. 20 meter per second. A is your correct answer. This is the end of this part. Thank you friends. Thanks for watching my video. Thank you.